This time on Finnegan's Garage, Game Over is alive. Watch this. Come on, baby. This is a huge day. We're about to recap the last 6 months of this 6-year-long turbo boat project. And today you're going to see us button up the last bits of fabrication, wiring, plumbing, the CO2 system on the boat. We'll explain what that's for. And finally, you're going to hear this 711 cubic inch Sonny Leonard twin turbo Hemi roar to life. Maybe we'll go on the water a little bit too. Okay, do me a favor and ignore the blue painter's tape and instead focus on the beauty that is that custom aluminum drive shaft. Yeah. Just mocked up right now, but it is in there. And below that, this right here will become a brace. Right now it's a flat piece of 6061 aluminum that is bolted to the intake of the jet drive. The intake of the jet drive is bolted and epoxied into the fiberglass boat hull. And then right now it's sitting on top of these frame rails in the boat, okay? Eventually, I'll make a mount that bolts from here to here to connect these two things. And then that connection point will stiffen everything back here. And as the fiberglass hull flexes, which it will, hopefully all of this bracing keeps that epoxy from cracking. The other thing it's gonna do is provide the bottom half of a safety collar for the drive shaft. I've got to craft an aluminum top half of this that'll go from here to here that will contain the drive shaft in case it ever breaks a U-joint and provide a mounting point for these threaded rods, which are bracing our precision turbos. Because as the headers get really hot, this stuff moves around. So we're gonna brace it here to try to keep the stuff from sagging when she's ripping across the lake. Here's the template for the part we're about to make. It's gonna go like that. It's actually gonna sit a little further down. I'll make it out of aluminum that is thicker than this plate, and then this plate will slide up an index inside of a slot I'm gonna machine into this kind of horseshoe looking thing. Here's our material. Again, this is 6061 aluminum. It is 5/8 of an inch thick, which is perfect because I'll mill a 1/4 inch slot in here so that this thing will drop down over that brace inside the boat, and then a bolt will go through it to sandwich it together. Peep that. There's our part. This, like I talked before, it's going to go right there. See it? Slides right over that plate. We'll drill a mounting hole there, mounting hole there. Then the strut bars, which support the weight of the turbochargers, will bolt right there and triangulate the whole thing. And right now what I've got to do is slide this on, mark where the holes are going to go, then drill these holes out so that I can bolt the two pieces together. And these are called transfer punches. And all they are is a punch that's designed to index into an existing hole. So if you look right here, that's going to go right there. This doesn't fit, I got the wrong size, so we'll go next size up. Oh, that's the wrong size too. Okay. There we go. All right. So that goes right there. That locates our hole. Then all we do is hit that with a hammer. Boom. Holes are marked, ready to go, and we go right to drilling. This is a 2.5 pound bottle of CO2, aka carbon dioxide. Same kind of thing that might power your kegerator at home if you're into that sort of thing. This is gonna run a whole lot of things in this boat. This CO2, combined with some solenoid valves and a regulator, are going to make the boat go forward and backwards. They're going to make the attitude of the boat adjustable, either up or down. They're going to make a safety device called a pop-off, ventilate excess pressure from the jet drive when we're hauling, but they will also be controlling the wastegates with CO2. All of that out of that bottle, and if there are no leaks in the system, that bottle should last at least the whole weekend, maybe more, of goofing around on the water. It's pretty awesome. Got the tube all tacked together. A couple of things to point out here. That end has a V-band clamp that is unique to Precision turbos. You got to get that from them because it's a different diameter than some of the other stuff out there on the aftermarket. This end is missing an O-ring. There'll be another O-ring right here, and there's the other one. This is what's called a dual seal connector. I got it from Race Part Solutions. It's made by Jodar. And essentially what this does is this goes around the whole thing and clamps it, sealing the two O-rings together while allowing that tube to have some movement, which is great because everything in this boat is solid mounted. Engine block mounted to aluminum directly to the stringers of the boat, turbos directly to the headers. All it is hard plumbing. There's no silicone connectors, which is why I have the dual seal there and the dual seal here on both tubes to give it enough movement where hopefully none of this stuff cracks. Cross my fingers, I've never done this before, but we'll see what happens. Building battery cables today for Turboat, aka Game Over, aka water skateboard. Somebody called it today on Instagram. I don't know. And anyway, pretty simple process. We're going to strip the shielding off the cable. We're going to slide on some Tech Flex shrink wrap. Then we're going to insert this into our hydraulic crimper that we got from wirecare.com. What we're trying to avoid is stripping so much that it hangs out in here. We don't want that. We don't want to strip it so short that we only get that much engagement. We want it right there, right at the end. So we're just gonna push down and rotate. See, we didn't cut any of the strands. We just cut the housing. And then it'll fit just like that, right in there. And it'll be the right amount. We won't have a bunch hanging out. This is 3-to-1 shrink ratio. WireCare also sells 2-to-1 and 4-to-1. 4-to-1 is pretty sweet because you can put it over the end of a connector and it'll still shrink down enough. Say the connector is that big, it'll still shrink down enough to tightly wrap around that cable. There we go, boom, right at the end there. All you do is slide that in there, slide that in there, insert your locking pin, turn it on. This releases the pressure, this increases the pressure, and as you see, this starts moving down. We're gonna get it started, and then we will put our terminal in. Okay, got some tension on there, make sure our wire hasn't fallen out. All ready? And you want to size this so that it crimps it tight, and as soon as the two dies meet each other, you're done. There's no point in keep pushing on it and trying to over crimp it because it won't do anything. Then you just release it right here. Pull it out, and what you're looking for is a nice uniform crimp all the way around, which we have. And we slide our shrink tube back down over it, melt that on there, and voila, we have a battery cable built, just like that. All right, this is a Steinel professional heat gun. We also got this from wirecare.com, and it will make short work of heat shrink. Done. Now that's ready to be put into service. Hubert and I made this. This is a center console for the boat. It goes between the front seats, and it's very important because it does a lot of things. First off, that's a cup holder. You can put frosty cold beverages in there. That's important. This right here, ignition interrupt. It's got a cap on it. It's by Mercury Racing. When the cap comes off, basically the motor shuts off. When does that happen? Hopefully never, but it's designed to be tethered to my life vest. So you put a little string on here, lanyard, clamp it to my life vest. If I ever get tossed out of this boat at high speeds, this will shut the motor off and keep the boat heading for shore at high speeds and searching for small animals. We don't want that to happen. These are all the buttons and switches to control the boat. Starter button, ignition, bilge pump, accessories. This is what's going to switch on and off all the important circuits in the boat. And we're going to connect this to the relay block using these cool aircraft quality connectors we got from wirecare.com. These are pretty sweet. And right now I'm going to show you how to assemble one of these because it's actually pretty easy as long as you have the expensive pliers. These are not cheap, and these are what allow you to take little tiny pins like this and put it on the end of wires and then insert that pin into this connector and have it work flawlessly. Watch this. This is the most important step right here. These pins are tiny and they go on the end of the wire, and the wire has to have the shield stripped a precise amount every time. You can't screw that up because it has to go that far into the connector, no more, no less. There's even an inspection hole in this connector that's really hard to see unless you have, I don't know, X-ray vision or a magnifying glass like I have here. So what you do is you strip the wire, and the best way to do that are pliers like these. These are from Pressmaster. These are adjustable here and here. This side will adjust the gauge of wire you're trying to strip. This side will tell you how long you're going to strip the wire. So this adjusts the depth that the wire goes in. This adjusts the thickness of the wire itself in terms of what you're taking off. And the reason you want to use something like this is so that every time you do it, it takes off just that amount right there. So that when it goes in there, you can look through the tiny inspection hole and see the wire inside. If you don't see the wire, it's too short.
If you do see the wire, it's perfect, and you move on to step number 2. Ready? Step number 2 is using the ratcheting pliers from DMC. It's a turret-style plier, and it ratchets. There's 3 inserts in there. This works for 12, 16, and 20 gauge wires. The way this works is you look at the chart, tells you what to set it to, and then you insert the pin through the bottom, make sure it bottoms out, and once it bottoms out, you ratchet this just like that, and it's done. It's crimped all the way around, perfect every single time. Give a little tug, you know that it's there. Once you've done all of these wires, you move on to the next step, putting them in the connector. And if you'll notice, on both sides of this, it is marked with letters. This is a 10-pin one. You can get these, I think, up to 50 pins, which is staggering. But if you're wiring something with EFI, you may need 50 pins. You never know. And it's helpful because I have a diagram that I've written down here, switch side, outlet side, so that I know on this side of the box what color the wires are and what they do, so that I can now wire this side right here. And I know that A is going to be my red wire. So I'm going to take the red wire, I'm going to find the letter A right there, and the key here is to put this in as straight as you can, so as not to tear the rubber part. And when you install it, they make tools for installing and removing these. The removing part I find you definitely need a tool for. The installing, I usually do it by hand. So that's in there. I'm going to do all of these, and then once I thread the cap on, the back of the cap will contact the rubber, squeeze it, and that's what holds all the wires in place. Now there are boots that you can shrink tube from the back cap onto whatever you have going over the wires. I don't have the right size here to show you, but if I did, I would. I don't. So right now what we're going to do is split loom this, shrink tube the end of it, and then later on when I get the right size boot, I'll shrink tube the loom to this and make that thing weather tight. Right now, here's a chance to show you something else that's cool. There's another awesome product from WireCare, and this is a tool for installing split loom that will save your sanity. All you do is install the tool onto the wires like that, rotate it over 180 degrees, spread the loom out with your fingers, put it over the tool like so, and then once it's on there, it's going to spread the loom and install it for you, saving you so much headaches and so many problems. Look at that. Look at how easy that is. You ever installed split loom before and I had to do it by hand without this? Forget about it. You'll never do that again. Look at that. Done. Like I said, now we just shrink tube the end of that together, and this is ready to install right here, and then this can go on the boat.
So something we haven't tackled on this boat in the 6 years I've been piecing it together is the electrical system. In this video, we're finally going to do that, and I'll show you how the heart of this is going to control everything. Holley Dominator ECU EFI system is going to run the ignition, the fueling, and it's also going to provide data acquisition to control all of the sensors in this boat, which is going to be really important the first time I drive it, because if you haven't figured out by now, nobody's ever done this before. Nobody's ever stuck an engine this large with twin turbos in a jet boat. So we're in unknown territory. Obviously, we want to be safe. So we're going to use a whole lot of sensors to monitor everything that's happening on the engine, the fuel system, the jet drive, the whole, like everything. All right. And here's the heart of it right here. So you can't see it now, but the Holley Dominator ECU is under the seats. This is a Speedwires fuse assembly here. It's got built-in relays, built-in fuses. It uses negative triggers on the input side, then activates a relay, and then outputs to anything you want to power. All right, so for instance, that's our starter relay. There's our ignition relay. There's our bilge pump relay. These relays here are going to power the injectors. They're going to power the O2 sensors. Everything we need to power right here. All of our data sensors are going to go right through this board here. So on this side are the sensors. On this side are wires going to the ECU. These are clippered spool valves. These are electric solenoid valves. They're going to control the flow of CO2 from our storage bottle to all the air cylinders in this boat that are going to control functions you'll see here shortly. These are our Holley boost control valves. This is going to supply and dump CO2 air to the wastegates to control the boost. And then, let me show you the sensors. So these are all pressure transducers. They're stainless steel bodies, 8th pipe. They thread into this billet manifold that I got from B1 Racing. These are all going to measure different pressures, temperatures, all kinds of things. For example, this one here is going to measure the water pressure coming into the jet drive in one spot. This will measure the water pressure coming into the jet drive in another spot. This one here will measure the water pressure exiting the jet drive. This one here will measure the vacuum in the crankcase of our engine. This one will measure the water pressure going through the engine. And why is all that stuff important? Well, not only does it allow you to tune the boat and the jet drive as it runs, but it also offers a margin of safety. So say the fuel pressure dips way too low and you're wide open, because I have a sensor on that, the ECU will see it and go, okay, if fuel pressure dips, but I'm still at 100% throttle position, we're going to destroy the motor. And when we destroy the motor, the boat's going to crash. Because unlike a car, I can't just push the clutch in. I can't throw it in neutral. If the motor locks up and you're going really fast, the boat comes crashing down, you get thrown out of it, and you're probably going to the hospital. So all of these sensors not only offer information, but also safeties that we can build into the Holley Dominator ECU to prevent bad things from happening. We put oil in the turbo boat motor for the first time in 7 years. And yes, I fogged the engine with oil in the cylinders before we started, but it hasn't really moved in 7 years. And she is now wired. She is ready to start. I can't start it right now because we have no program in the ECU, but what I am going to do is prime the thing through the dry sump pump, get oil to the top end, and then just maybe click the starter motor just a little bit, just to see it, just see some action. And then next week, we're going to fire it. So right now I've got a drill motor going to the front of the daily engineering dry sump pump, and I have a cocktail in my hand because this may take a while, and we're just going to spin it, see if the oil moves.
Oh, look.
Oh, we got oil out of one rocker. That means, because it has priority main oiling, that means the main bearings have oil, the cam bearings have oil. Good sign. And I'll keep going. Most of the rocker arms will get oil, not all of them, because they're not all lined up perfectly right now. The lifters,
We'll have to rotate it.
The lifters are not all lined up with the oil gallery in the cam tunnel. But I'll get oil out of most of them, and then we'll bump the starter and prime it a little more, and soon we'll have oil out of every rocker arm. Oh yeah. I got oil out of half of them already.
I got 4 of them over here.
I got all of them over here.
I got all of them. All but one. Keep going. Got one more. Bam! All right, we're good.
Every single one of them. That primed quick.
Yeah, it did.
And look at that. That was off of a cordless drill motor in Milwaukee.
You doubted me.
I did, because in the past, like most big block Chevys, I can burn up a drill motor, and it can take 10 minutes to get oil to the top end. That came right up. Yeah.
let's talk about the fuel system, because that's another unknown quantity here with this boat. Because the engine is so large, because it's going to consume so much fuel, and because it's capable of making a lot of horsepower, I didn't go an electric fuel pump this time, even though recently there's been a lot of advancement in electric fuel pump technology, and you can get one that will be reliable and will work perfectly. But there's a few things about this boat that really steered me away from using an electric fuel pump. First off is this is already a really complex build. I don't want more wires in this. It's already got a ridiculous amount of wires. Second, we have round stainless steel IMCO fuel tanks in this. And putting an electric fuel pump near them, on them, in them, not easy. So I ended up going with an Aeromotive belt-driven mechanical pump, which is right here. This is more than capable of feeding this engine and engines that are even bigger and more powerful in it. What we don't know is when you're cranking the engine over at, say, 140, 150 RPM, will this be able to siphon fuel out of these tanks and provide enough pressure to the injectors for this thing to fire? That I don't know. A lot of people that run mechanical pumps also run a small electric pump to prime the fuel system. I'm trying to avoid that as well. So when we're all done here and Robin Lawrence from Holley shows up, I'm going to drop the bomb on him that, hey, I don't have a priming system. I just have this. I'd like to try to make it work. So we'll see what happens. Basically, we've got round fuel cells going to a Y block, going to that mechanical pump, going through that filter to these fuel rails, and then out of the fuel pressure regulator through a ball valve that's similar to the one on my 55 Chevy, and then returning back to both these fuel cells. And I'm hoping it works. This is a big moment. There's never been fuel in this boat. I hope it doesn't leak, because I know who worked on it. This is it. The moment we've all been waiting for after, I don't know, 6 years of wiring, plumbing, planning, fabricating. Game over is ready to run. Not necessarily lake test, but today is the day we are going to light off the 711 cubic inch Sonny Leonard twin turbo Hemi. We've got a digital dash here. It's going to do everything, and I've wired it. I'm confident it's ready to go, but we wanted an expert here to make sure the first fire up goes well.
He wasn't available, so I'm here now.
Yeah, we'll take Robin. You know, beggars can't be choosers.
That's right.
So right now, I think what we're going to do is we're just going to crank it, get the air out of the fuel system, make sure we have fuel pressure, make sure we have oil pressure, and
Crank signal, make sure we get RPM.
Yeah.
Cam and crank sensor will be synchronized.
yeah.
Make sure we have that. Put the fuel line back on, make some noise. I'm ready anytime you are.
The rest of you out there, you haven't lived until you sat this close to an engine this big. Well, any engine for that matter. Yeah. Cars, not nearly as crazy as boats. Shall we?
Yes, sir.
We have oil pressure, we have fuel pressure. I'm pushing the start button, man. Let's do this. Go, baby. We don't have enough fuel pressure at all.
It's doing, well, any fuel pressure in that rail
Okay.
is going to piss a little bit in there.
Okay,
So
good.
we don't have to have full fuel pressure.
Because that
So
was like 5.
if we got 5
Okay.
and the injectors are open now, it might not be enough fuel.
Okay.
So let me do something here real quick.
All right.
Um,
So here's what's going on. We have a belt-driven mechanical fuel pump on this motor. And we have that because after talking to a whole bunch of different folks, when you make this kind of power, it's a more reliable setup than most electric fuel pumps. When I started putting this together, the electric fuel pumps that were out there, I don't know, I just wasn't into it. Since then, there's a whole bunch of really good electric fuel pumps out there that I'm totally confident would feed this, but that's not what we have. So we don't have anything priming the engine ahead of the time when it starts. And normally in any late model vehicle or any fuel injected engine, the moment you turn the ignition on, you get fuel pressure and the injectors cycle and put fuel into the motor. Right now when I'm cranking it, it's trying to build fuel pressure while that's happening, and so we're gonna have to make some adjustments in the fueling of the computer part of things to try to get it to start. And if we can't make all that work out at some point, I'm going to have to supplement the belt-driven fuel pump with an electric pump, which I don't want to do because that just adds more wires and more complication to this already complicated thing we got going on. All right, overcome 2 problems today. 1, fuel system not wanting to prime. That's fixed. 2, no cam sensor functioning. Just fixed that. We had to drill out the cam gear. I don't think we videoed any of that because we're in such a hurry to make it run. But I'm confident it's going to pop and fart and roar to life, which is why I have my shades on, because, you know,
That's the problem. We never had the shades on before.
That's probably why it didn't work.
That's exactly it.
Yeah. All right, it's gonna work now. Ready?
Go ahead.
Did you hear that? It made noise. Oh, it's been like 6 or 7 years, dude. That was cool.
You fire it?
Yes, I do. Here we go.
Foot speed a little bit.
Yeah?
Yeah, a little bit.
All right. A little bit of throttle here. Oh, it's so rowdy, dude. This is how committed I am to this right now. Brand new garden hose that my wife uses to, you know, make the plants grow. It's about to become a valuable portion of today's project, which is starting the boat. And we're gonna push the boat outside right now and fire it up and warm it up and run it. And I need a fresh water source to the engine because it's a boat. There's no radiator in it, it's a drag boat. So I'm gonna plumb this directly from the house to the boat and then apologize later when she can't water the hydrangeas or whatever the heck those things are called she's got in the backyard. I'll get her a new hose. Come on. There we go. All right, let's push the boat outside and fire it up again. Woo! It's a good day. She'll understand. This is definitely not as bad as taking off on Valentine's Day to buy a truck that never made it home. It's not like that at all. Love you, baby. All right, let's go. Sun's out, lake's completely flooded. I see whitecaps in the marina. Let's go find out if the boat floats. We'll start there. If it floats, maybe we'll see if it idles. If it idles, maybe we'll see if it drives around the marina, you know, at a leisurely pace. This is exactly when you want your maiden voyage to go down. Yeah. Dude, it's 50 degrees in Georgia. You know what that is? That's practically springtime. So I'm gonna take it. I'm in shorts and a flip-flop. I'm taking it. I need to pull the covers off the turbos. Dude, the wind is insane right now.
This is probably 30 or 40 mile per hour winds right now.
Not ideal conditions, but like I said, I was having a bad day. My dog, I found out we have to put down. I'm bummed out. I thought, well, the sun's out. Let's just go see if the boat floats. That will improve my mood substantially. Right now, what we're gonna do is we're gonna back it in, stand at the back of the boat, see if it leaks. If it doesn't leak, we'll see if it starts. If it starts, we'll see if it wants to idle. If it idles, we'll put it around the marina. Beyond that, we're not doing anything else because there's legit white caps everywhere outside of the marina. And as you can see by that dock that's sunk, it's rained so much in Georgia that everything's flooded. It's not a good time to go boating. It didn't sink, but we lost something.
Oh no.
I'll just let you look around. Maybe you can spot it.
How'd that happen? Like, how is that held on there?
Well, it's held on with a clamp, and my guess is not only was the clamp not tight, but these weren't tight because this one lost a plug. That one, the entire cap fell off the wastegate, and but if that's all that went wrong for launching this thing, you know, in this, after 6 years, I'm okay with it. Here's the real telltale. We didn't sink it. I took some water over the back because of the wind. But,
that wasn't very much at all.
Overall, not a bad maiden voyage. Not bad at all. We'll get another cap for our precision wastegate. We put the bilge pump in like 5 minutes before we came down here, so that's temporary. We'll fix that. We'll make that nicer. Hopefully the boat doesn't just, you know, run ashore and run over any small children. Did I just say that? Yes, I did. Let's start over.